Well, we have another question here, question 6.1. The question says that given g of x equal to 3 to the power of y. So 6.1, we have g of x equal to 3 to the power of, 3 to the power of x. And then 6.1.1, the question here says that write down the equation of g minus 1 in the form y equals to. All right. So g of x is y equal to 3 to the power of x. Now, to find g minus 1 then is when we switch the variables x with the variable y, okay? So instead of writing y, I'm gonna write x, and then x equal to 3 to the power of y, okay? So I'm gonna work out, I'm gonna make the y subject of the formula. I'm gonna write here 3 to the power of y equal x. Now, there is a property for logs functions because the inverse of exponential functions are logs and vice versa. The property says that b to the power of x equal a implies that x equal to log of a base b. So in this situation, y is, okay, this x here is that y. So we're gonna say y here. So y will be equal to log of a base b. So a is x, and then b here is 3. So that's gonna be x base 3. So this is the form y equal to of this inverse function g of g minus 1. Now, the following question is question 6.1.2. Excuse me. The question says that point 611, point P611 lies on h of x equal to x minus 3 to the power of x minus 4 plus 2. The graph of h is translated to form G. Write down the coordinates of the image of P on G. Okay. So I'm gonna write the question over here. That was 6.1.1, and now 6.1.2. So okay, we're looking for the translation of P, okay, on G. I can call it P prime now. Initially, P was given by 611. Okay, now the function h is h of x is equal to 3 to the power of x minus 4 plus 2. So this notation tells us something, okay? The minus 4 here tells us that it is shifted, the same graph, okay, of the same graph which is shifted 4 units to the right, okay? And then 2 here shifted 2 units to the left. But now, because we're going back to the initial function, actually, excuse me, I want to say 4 units shifted to the right and then 2 units up, okay? But now, because the point P is here, we need to get the point P on the equation of G. It's going to be like the inverse of this. It means 4 units to the left and then 2 units downwards. So 4 into the left, meaning we're going to minus 4 over here from 6, and then we're going to 2 units down, we're going to minus 2 from 11. So the point P will then become 2, 9. Okay, I need to say it over one more time, explain differently maybe. I said the initial function G was 3 to the power of x, okay? And now when we see something like this, we understand that this is a translation of this function. Now this means the same function 3 of x shifted 4 units to the right and then 2 units upwards. Okay, now it is said that the point P here lies on this graph. That was the translation of G. Now, if we need to find now the translation of the same point P, okay, on G, then meaning we're gonna do the opposite of what is here. Okay, we're gonna shift the point 4 units to the left, and then 2 units down. So we got P equal to 2, 9. That's the point P, 2, 9. Now, question 6.2, the question says that sketch is the graph of f of x equal to 2 to the power of x plus p plus q, and then t is the point 3, 16 is a point on f, and the asymptote of f is y equal to negative 16. Now, the question is determine the value of p and q. All right, so I'm gonna move my board like this. So 6.2, we need to determine the value of P and Q. P, Q is what we need to find. Okay, how can we do that? So f of x then, f of x is given by as we read it there, it's equal by 2 to the power of x plus p minus q, no plus q, let's double check. Yes, plus p, okay, and then plus q there. So now the asymptote is by negative 16 there. Okay, the asymptotes, the horizontal asymptotes. So the value, this q value stands for the horizontal asymptote. Okay, we can substitute the horizontal asymptote. So this would be f of x. I meant to say horizontal asymptote, excuse me. That's going to be like 2 to the power of x plus p plus 16. Okay, and then there's another point, another given point in the graph. It's the point t, the point 3, 16. So we will substitute 16 for f of x because that's the value of y. 16 here for f of x equal to 2 to the power of 3, okay, at that point, plus p plus 16. Okay, now, not plus 16, but minus 16 because it was negative 16, the asymptote. Negative 16. So if I move negative 16 over, we'll have like 16 plus 16 equal to 2 to the power 3 plus p. And then that makes 32 equal to 2 to the p. Okay, p plus 3 is the same thing. Now, 32 can be written as, in terms of its prime factor, is 2 to the power 5. Okay, 2 to the power of p plus 3. In case you don't see why I say this is equal to 2 to the power 5, you can use a calculator. Okay, in your calculator, press 32. Okay, and then press the equal button here, and then press shift, and then press the button underneath here, effect. You see a button effect there. When you hit effect, and then it will give you the prime number of 32, which is 2 to the power 5. Now, according to the exponent property, that says a to the power of m equal to a to the power of n, this implies that m equal n. So in this situation, we're just going to drop the basis, and then we equate the exponents. So this would be a 5 plus, sorry, I prefer to start by writing p plus 3 equal 5. So if I move the 3 over, like p equal to 5 minus 3, which is 2. So the value of p is 2. And the value of q is the horizontal asymptote, which is 16, negative 16. Thank you.